applications. Her ability to bridge theoretical machine learning concept with practical application make her an excellent guide for today's session. Today's talk will help us understand the fundamental concept of machine learning while also exploring how these techniques are applied across industries and research domains. Please join me in welcoming Dr. Needu M. Ma'am, the virtual platform is yours.
Thank you. Good afternoon, everyone. A very warm welcome to all of you joining us today for the Faculty Development Program session. I am Dr. Needu M, Associate Professor, Department of Computer Science and Engineering, Jodhi Engineering College. It's truly a pleasure to be with you all today. So today, I will cover the fascinating world of machine learning. That is what it is.
Hello, ma'am. Excuse me, ma'am.
How it works and its major types applications. This briefing of the facet of AI is simple. That is simple to say. Hello. Hello. Any issue?
Hello, ma'am. The voice is breaking.
Yes. Okay. So the fundamental goal of AI is simple to state. That is getting machines to simulate human uh, uh,
Dear participants, please wait for a minute. There is some problem with the network. Let her rectify that. Please wait.
Am I audible?
Yes, ma'am. Yes, ma'am. It is okay now.
Hello? Okay. Thank you. Hope this screen is visible to you all, right?
Yes, ma'am.
Okay, thank you. So as we all know that fundamental goal of AI is simple to state, that is getting machines to simulate the human intelligence. So the question that is driven, okay, So that question has driven in the field of that AI for the several decades. That is Turing, that is vision gave us a goal, and generations of research have been working towards achieve that goal. So in the textbook of artificial intelligence, a modern approach that is defined by AI as a study of agents that receives information from the environment and will perform the actions based on that information. So they also outline that in historical approaches which will define the field of AI, that is about that thinking humanly, thinking rationally, and acting humanly and acting rationally. So thinking humanly is nothing but it is building systems that mimic how humans think, and thinking rationally, that is use logic and reasoning. Then acting humanly in the sense that system that behave in a way which is distinguishable from the human, and acting rationally, that is system that act to achieve the best possible outcome. Here, the first two are about that thought process and reasoning, that is thinking humanly and thinking rationally, while the last two, that is acting humanly and acting rationally, it is based on the observable behavior. So this distinction matters because it shapes that which tools and which techniques that are used. So AI, it's a computer-able system that is perform tasks that requires human intelligence. So many of these artificial intelligence systems, which is powered by machine learning, and some are from deep learning, and some are that is things which will rules the society. So very boring these rules, it means that AI is very good, but that exciting in line today is machine learning and deep learning. So let me quickly list out some of the applications in everyday, that is smart assistants, then smart spam filters in our email, then Netflix and Spotify recommendations, then face detection, then fraud detection, then disease mapping and diagnostic prediction tools. So all of these have some element of AI, then which is most of them that is crucially involved the machine learning at their core. Then next comes that what is machine learning? So let us focus on machine learning specifically. So think about how human learns. That is, we learn from experience, right? When we are considering a child that who touches a hot stove, so once he learns that never to do again. That is a doctor who has seen hundreds of patients, which develops in that intuition of diagnosis, and he doesn't need a textbook in order to say medicine name and all. So traditional computers, on the other hand, which will explain the instructions that is given by human, that is, we give the machine rules and we give it data and it produces answer. So look at the diagram, that is, it captures the essential differences, that is traditional programming and machine learning. So traditional programming, machine learning, that is in the traditional programming, that is data plus program, and the machine learning data plus output, that is program logic. In the sense, in machine learning, if we flip the set of ideas, that is instead of writing the rules ourselves, what we are doing is we feed the machine data and the correct answers and let the machine discovers the rules on its own during training. So we then evaluate that learned logic during testing. So this is a shift that is simply to state that, but it is very difficult to analyze. That means the machines can handle tasks which are too complex and too data rich for a human to write rules for manually. So it is not just about speed. That is, machine learning involves that understanding and reasoning from the data. And critically, when the data is more, that is more data we have, the better the model becomes. That is explosion of data in the digital age had made a significant role in the machine learning, which is more powerful. Then Arthur Samuel, which will point out in 1959, that is who defined the machine learning as the field of study which will give the computer the ability to learn without being programmed. That is, it's a SAML is a computer who works, who wrote on the self-learning program that plays checkers, and the program which actually got better than when more it played. So he invented the alpha beta pruning technique, which is still widely used in the decision tree searching today. So why does the machine learning matters? So it is that is machine learning has given us the self-driving cars, then practical speech recognition, that is voice assistant on our phone, then effective web search, that is how Google understand and what we actually mean, then improved understanding of the human genome. And this is not an incremental improvements. These are only the transformation capabilities. So this machine learning, as we already told, that works through three core processes, that is a decision process, an error function, and a model optimization process. So in a decision process, the algorithm which analyzes the input data and it makes a prediction or classification which is based on the pattern that it has learned. Next, an error function that will evaluate how accurate the prediction is. Okay, did the model get it right, or how much was it wrong, etc. And the model optimization process, in the sense the model adjusts itself, that is maybe specifically it updates the weights of the neural network, or it repeats the evaluate and optimize cycle until it will reach a satisfactory level of accuracy. So this is actually a loop function, that is predict, evaluate, and adjust, which is the heartbeat of what we say that machine learning. So actually there are four major types of machine learning, that is supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So in the supervised learning, it uses the labeled data. Unsupervised learning uses the unlabeled data, and semi-supervised learning, that is, it is the mix of both, that is labeled as well as the unlabeled data. And next is reinforcement learning. It is reward-based feedback-driven system. So this diagram, that is machine learning taxonomy diagram, which will give you a clear overview. Let us go through each one detail. That is machine learning, that is supervised learning, unsupervised learning. So supervised learning is about classification and regression, and unsupervised learning, that is clustering and association. So let's see in supervised learning. So this supervised learning, that is we train a model on a labeled data. Okay, so that is data which we are already know the correct answer. Like that, when you are thinking about a student who is studying with answer key. So for every practice question, the student can check whether the answer was right or wrong, or he can learn from the mistakes. Okay, so like that, this model learns to predict a label when we give a new set of features. So it can be two types, that is classification and regression. So classification is nothing but when the label data is a category. For example, if you are considering the email, that is the message is spam or not. If you are considering a tumor, whether it is the tumor is malignant or benign, etc. And regression in the sense when the label is a continuous value. If you are considering the temperature of tomorrow and what will be the predicted price of the house of today, etc. So this is the classification versus regression diagram. So in this classification diagram, you can see two distinct groups that is separated by a boundary line. So in the regression diagram, you see a trend line that is fitted through the data point. That is, the model is predicting a continuous output. So let us see the summary of that supervised learning. That is, once a supervised learning is trained, once a supervised learning is trained on a label data, it can make predictions on new or unseen data whose features which are known, but those labels are not known. That is, once a supervised model is trained on the label data, new predictions can be happen. Then the Q algorithms or the supervised learning algorithm includes that linear regression, then K nearest neighbor, decision trees, then support vector machines, neural networks, logistic regression, then gradient boosting, etc. So linear regression means that predicts a continuous value, and that K nearest neighbor, that is classifies by looking at the K closest data points, and decision tree is nothing but that is branching rules that split data, and support vector machine which finds the optimal boundary that is between the classes, neural network which is inspired by human brain, that is the which is the foundation of what deep learning. Then logistic regression, which classifies the data into two categories and despite of the name. Then gradient boosting, that is sequentially corrects the error which is from the prior models. So these are the real applications or real world applications of supervised learning. So first one is that is finance, that is that credit card fraud detection, that is the transaction is fraudulent, and the email we are considering that the spam detection, is the message is spam or not. And if you are considering the marketing area, the text sentiment analysis, that is the customer review of a particular product is either positive or negative. And in the case of healthcare, that is medicine, that for predicting the patient high risk, that is high risk or low risk, that is patient risk condition can be analysis. So these are all the cases where we have historical label data and we want the model to generalize this inputs. So next comes that unsupervised learning. So if you don't have the label data, okay, if you don't have the label data, that is what we have simply have a large collection of data points and want to find the natural structure within it. Okay, so if we don't have the label data and if we simply have a large collection of data points and we want to find the natural structure within it, that is what is unsupervised learning. That is, there is no predefined labels. Here only we are considering features. Okay. So the algorithm which explores the data and discovers the patterns or grouping on its own. So it consists of two primary tasks, that is clustering and dimensionality reduction. So clustering, when the output is discrete, that is a group similar data points which is gathering together. And in the case of the dimensionality reduction, when the output is continuous, that is represent data using only few features while preserving the important information. Okay, that is clustering when the output is used when the output is discrete. That is, it's a group of similar data points which is together. So here we have mixed a group of that is unsupervised learning, that is clustering and dimensionality reduction. So for the clustering example, let us consider, or the unsupervised example, let us consider the cartoon characters. Okay, the cluster or this cartoon character, we have a mixed group of Disney and Looney Tunes characters. That is, an unsupervised algorithm will look at the visual features and accordingly it group without ever being told that this is Disney and this is Looney Tunes, etc. So it will consider the visual features and accordingly it will group. And the cluster which does not tell you that this is the label, and it only tells about the points within each cluster and more similar to each other than to points to the other clusters. Okay, so it doesn't tell you about the label. It is up to the data scientist, or it can be interpreted by the cluster means, etc. So this unsupervised algorithms are k-means clustering, then density-based spatial clustering, then balanced iterative reducing and clustering, then hierarchical clustering, then PCA, that is principal component analysis, singular valuation decomposition, then independent component analysis. So K-means clustering is nothing but partitioning data into K clusters. And DBSCAN, that is density-based spatial clustering, it is good for finding the clusters of irregular shape and handling noises. And the hierarchical clustering is build a tree of clusters, and the PCA that is most commonly or widely used, which is used for dimensionality reduction technique. And the singular value decomposition or SVD, which you extensively accommodation systems, and the independent component analysis, that is ICA, which will separate the mixed signals, which is used in brain signal processing. Next is unsupervised learning summary, that is real world application. So the first one is customer segmentation, that is grouping customers by purchasing the behavior, that is so has to company can personalize its offerings. Next is image segmentation. Here the partitioning an image into a meaningful regions, that is image segmentation. Next is anomaly detection. So identifying the unusual patterns that is which will deviate from the normal, which is that is relevant to the cyber security or the equipment fault detection, etc. That is unusual patterns, and identifying the unusual patterns which will be which there will be a deviation from the normal structure. So so in the table that is summarizes the relationship, that is discrete supervised classification, and the continuous supervised is regression, and discrete unsupervised is clustering, and continuous unsupervised is dimensionality reduction. So next is semi-supervised learning. So semi-supervised learning that is occupies a middle ground, that is it uses only the small amount of labeled data. The small amount of labeled data which is combined with a large amount of unlabeled data. Okay. So because of handling the data inexpensive, that is it is time consuming, and it often requires the expert human judgment, that is in many domains we have an abundant raw data but very little that has been labeled. So this approach, that is semi-supervised learning, this approach typically works by using that unsupervised technique to predict the labels for the unlabeled data, that is feeding them those predicted labels into a supervised technique. This process will increase that accuracy, and when compared to small labeled set alone. So next comes the real-time applications or practical applications of semi-supervised learning. The first one is speech analysis. So speech analysis, in the sense, it's labeling audio recordings is extremely labor intensive, right? That is semi-supervised learning methods which allow us to allowed to store that large amount of unlabeled audio. And next is internet content classification. So labeling every web page, that is labeling every web page is not feasible. So this semi-supervised method helps to classify the web content. And next is protein sequence classification. That is, as we all know, that DNA strands are long and complex, that annotating them manually requires that highly specialized expertise. So this can be done by using semi-supervised learning technique. So this summary diagram or the training data comparison, this diagram captures the three types visually, that is supervised. It consists of all labeled data, which is a model, and the semi-supervised, that is some labeled plus lot of unlabeled, that is also a model. Then unsupervised means all labeled data. So next comes that reinforcement learning. So in the reinforcement learning, that is one of the most exciting in the field of robotics and autonomous system. That is Consider a child who learns to walk. Okay, so no one will give that instructions to the child that, or we are not giving any instructions like by its biomechanics or locomotion. So the child tries. If he may fall, then he adjusts. He again tries, and that is guided by the feedback of what works and what does not. Finally, what happened? The child will walk. So this is a simple example for a reinforcement learning. Okay, that is reinforcement learning or the RL technique, which enables an agent to learn in an interactive environment through trial and error. Okay, that is using feedback from its own actions and experiences. What a child is doing. Initially, he tried to stand, he falls, he adjusts, he again tries. Finally, what happened? The child will walk. The same process or the same mechanism is happening in the reinforcement learning. And the key components of the reinforcement learning are the agent, that is the learner, and the decision maker, and the environment, that is the world the agent reacts with. And the actions are the set of things that agent can do. And the state is nothing but the current situation of the agent within that environment. And the reward is the feedback signal the agent receives after taking an action. So the agent's goal is to maximize its cumulative reward over a time. That is, it learns a policy that is a mapping from states to action. Okay, that is a mapping from states to action in the sense it achieves this. That is, its advantages are the probability of it accounts for that probability of occurrence, that future outcome. It's not an immediate result. Okay, that is probability of future outcome. It's not an immediate result, and decisions are made sequentially. That is, each output influences the next input. So that is here the key components, that agent, environment, then action, the agent, that learner and the decision maker, and the environment is the world that agent reacts with. Okay, then finally what happened? The action, that is set of things which the agent can do, and the current situation of the agent within the environment, and the feedback signal the agent receives after taking an action. So this is the diagram for the reinforcement learning feedback loop. That is, the agent observes the state, it takes an action, it receives a reward from the environment, and the environment transitions to a new state. That is, the agent repeats this cycle, which gradually learning which action yield the highest reward. So this reinforcement learning algorithm, first one is temporal difference. That is, it learns from that incomplete episodes. That is accordingly. That is, next is Q learning. That is, learns the value of actions in each state. That is, it is the foundation of all gaming playing AIs. Next is deep adversarial networks, which will combine the deep learning with the reinforcement learning. So next is the reinforcement learning, that summary and its applications. So it's real-time applications and robotics, that is industrial automation, robotics arms that we all know, that is that learn to manipulate the objects. Then gameplay, that is AlphaGo, which defeated the world champion at Go, that is chess engines, then video game boards, etc. Then autonomous vehicles, that is learning to navigate complex traffic scenarios. Then planning problems, that is travel route optimization, then budget planning, then business strategy optimization, etc. Next comes the key terminologies of machine learning. So in the key terminologies of machine learning, that is, first one is model. So model is nothing but a specific representation which is learned from data by applying a machine learning algorithm. So this model is the what to say, this model is the output of training. That is why we implement that predictions. Next is feature. So an individual measurable property of the data is what we call as feature. That is, if you are predicting, for example, if you are predicting the predicting house prices, features might be include that number of rooms, then square footage, then location and age of building, etc. So that is individual measurable property of the data is what we call as feature. Next is feature vector. It's a set of numeric features that is described together. So that is every data point in our data set is represented as a feature vector that which is fed as input to the model. Okay, that is it is a set of numeric features which is described together. In the feature, an individual will measure the property of the data. That may be, for example, it includes only small properties. Here with feature vector, it consists of a set of numeric features which is described together. Okay. Next is label or target. That is the value we are trying to predict. So in the supervised learning, the label is what the model learns to output. And in training, next is training. So this process of feeding, that is process of reading the model input like features and their expected outputs, their expected output in the sense labels. So it can be learned the mapping between these features and labels. Okay. So training, it is a process of feeding the input. That is, input can be feature and this output is the label. So it can learn the mapping between the inputs and output in the sense between the features and labels. And prediction, once the model is trained, we feed it new, right? That is unseen inputs and it produces a predicted value is called as prediction. Then during training, the inputs are during training that that is terminology in the figure. That is during training, the inputs which will go through the feature extraction and into the machine learning algorithms, which will learn from both features and labels. Okay. So first diagram is about training and second is about prediction. So first, during training, the input that is go through the feature extraction, which learns from both features and that is input and from the output. And second figure, that is during prediction, that is new inputs go through some of the feature extraction. Then it will to the trained classifier model, which outputs a predicted label. That is training versus testing diagram. So during training, the data and algorithm work together to generate a logic. And during testing, that logic process, that is new input to produce output, this separation is critical. And the model must always be evaluated on the data it has never seen during training. That is during the training, and during the training, the data and the algorithm that is work together. And during the testing, the process will repeat, and this separation is important, and it will evaluate the data after that. So next comes the how we split the data in machine learning. That is data splitting and evaluation. So let us talk about how we are evaluating a machine learning model first. Okay. That is the standard practice in the machine learning is to split our data into subset. That is training data. As we all know, the portion is used to train the model. And this model sees that the data and learns from it. Okay. So first part is training data. And next is the validation data. It's nothing but it's a portion which is held for a frequent evaluation, held aside for a frequent evaluation during training. And it helps to tune the hyperparameter. That is, it's the configuration settings of the learning algorithm without making any problem to the data set or without contaminating that data set. Next is testing data. So once the model is fully trained and tuned, next process is to evaluate it one final time, right? So that is on that test data. Okay. So this provides, that is testing process provides an unbiased and estimate the real world performance. Why? Because this model has never touched this data. Okay. So here the data splitting and evaluation consists of three parts: training data, validation data, and testing data. So we can say this is typically split of something like 70% of training, 15% of validation, and 15% of test. So this will vary based on the data set size. Okay. So based on data size, this proportion may vary. Then evaluation matrices for the supervised learning, that is classification, that is for classification problems. The first evaluation matrix is accuracy. So accuracy is nothing but it's a proportion of all predictions that we correct. That is simply, but that is many problems or which will mislead with the unbalanced classes. That is, accuracy is correct prediction by the total number of predictions. And recall, in the sense, it is a number of true positives divided by number of true positive plus the number of false negative. That is, if you are considering the data set, all the times the model is predicted positive, then how often it is very actual positive among this true positive, and it will help to reduce the false alarms. Next is recall. So recall of all positives, that is how many did the model accurately identify. That is, if it minimizes any missed predictions, that is called sensitivity. So in the medical diagnosis, the recall or sensitivity is very important. That is, we should not miss the real data. That is, will make many problems. So in medical diagnosis, recall is very important. Then that is for supervised learning, that is regression, that is mean absolute error, then mean squared error, then root mean square error. These all measures how far the model's predictions are from the true values. And then for unsupervised labels or unsupervised learning, so here there is no correct labels to compare against. That is, here the cluster homogeneity means that is all points in the cluster which will belong to the same true class. Or in the case of random index, it's a measure of similarity between two clusterings of the same data. And in the case of a reinforcement learning, so in the case of a reinforcement learning, it's based on the evaluation. That is, evaluation is built directly into training. That is, a reward signal is an evaluation mechanism. So this mechanism is used as an agent to perform and assign tasks, and higher the evaluation, the more the cumulative reward. So here for this unsupervised learning, for the supervised learning, it's classification. Then for supervised learning is regression also. And for the unsupervised learning, it's about the cluster homogeneity and random index. And for the reinforcement learning, it's based on that reward signal. That is, it's an evaluation mechanism. When the agent performs its assigned task, then higher the cumulative reward. So these are about this algorithms are used in that pre-learning mechanisms, that is supervised learning, unsupervised learning, and reinforcement learning. So next comes that applications of machine learning. So applications in the sense, as we all know, that is key application domains of this machine learning. So first one is healthcare. So in the field of healthcare, that is early disease detection, that is personalized treatment recommendation, and also for the drug discovery. And in the case of finance, that is fraud detection, like that credit scoring, then algorithmic trading and risk assessment, etc. And the natural language processing, that translations about that chatbots, and including the AI systems which us interact with daily. And the computer vision is, that is image classification, then object detection, facial recognition, and medical imaging, etc. And in the case of e-commerce, that customer behavior prediction, that is based on that customer behavior about a product, whether it is good or bad, and about the recommendation engines and the dynamic pricing, etc. And in the case of robotics, that is industrial automation, that is autonomous manipulation, and it's a collaborative robots, etc. And in the field of computational biology, that is protein structure prediction, then Webvan search engine, that is Google's search algorithm, then in the case of email for the spam detection and personal content ranking, etc. And in the case of autonomous vehicle, that is self-driving cars, then drone navigation, etc. So these are the common threads across all this, that is large amount of data, then complex patterns that human cannot easily identify as tools, and the need of system which that improve more data and experience. So here we are covered that only the substantial amount of ground data. So let me have a quick recap on this. That is, AI's goal is to stimulate the human intelligence. That is, machine learning is an AI's that most powerful current implementation, and it differs from the traditional programming by learning rules from the data rather than following a pre-coded instructions. Okay. So here the four major types are supervised, unsupervised, semi-supervised, and reinforcement learning. And each will suited to different data situations and problem types. And the key terminologies what we used here is model, feature, label, training, testing, prediction, etc. Then here the evaluations must always done with an held out data, and the model will never see. And this machine learning applications plays an important role in all the industry domains. These are about machine learning. That is, this is only the basic concepts of machine learning and the basic algorithms that we are using in the machine learning. This is only a ground. So thank you all for your time, your attention, and your engagement today. Thank you.
Thank you, ma'am. Now, participants, if you have any doubts, please. Ma'am, hope there are no more queries. So, officially, I thank you, ma'am, for your insightful talk on machine learning fundamentals for approaches and real world applications. It was a wonderful talk delivered by you. Next, I formally invite Ashik MS to
deliver the word of thanks.
Good afternoon, everyone. On behalf of the organization committee, I would like to sincerely thank Dr. Nidhi for delivering such an informative and engaging session on machine learning fundamentals for applications and real-world applications. Today's session provides us with a clear understanding of the fundamentals of machine learning, its core approaches, and its real-world application in different fields. Explanations, examples, and practical insights shared during the session were highly useful and inspiring for all the participants. Thank you for taking the time to share your valuable knowledge and experience with us. The sessions was truly beneficial and enlightening. I also extend my heartfelt thanks to all sirs for making this program a very successful. Thank you all. Have a wonderful day.
Thank you, ma'am, and thank you all participants. Now, before concluding, may I invite Ms. Shrishma to provide overall report about the 6-day FDP.
Thank you, Naini ma'am. So, the Department of Mechatronic Engineering, Jyoti Engineering College, in association with the Institute of Engineers and the Indian Society of Technical Educations, ISTE, have successfully organized a 6-day National Faculty Development Program of AI-driven robotics and vision system theory to practice from 8 June to 15th June 2026. The FTP was designed to provide participants with a comprehensive understanding of emerging technologies in artificial intelligence, robotics, computer vision, and their real-world applications. The program commenced with the inaugural session and keynote address by Engineer Amit Raman Sir, CEO of Ingar Robotics, who also delivered an insightful lecture on Foundation of Intelligent Robotics. This was followed by Dr. Danu K. Danpal, Application Engineer, Coral Technologies, who conducted 2 sessions on MATLAB and simulation tools. And on the second day, he delivered AI-powered computer vision for robotics. And the second session was by Dr. Akhil VM, Assistant Professor of Amrita Vishwa Vidyadeepam, Coimbatore, who delivered an informative session on AI in robotic surgery. And the third day featured Dr. Mervyn Joe Thomas, NIT Surathkal, who discussed intelligent medical robotics, recent research and applications, which is followed by Mr. Jinesh KJ, Assistant Professor of Jyoti Engineering College, who introduced participants to YOLO, You Only Look Once, and its application in object detection. And the next day included an engaging session on visual intelligence for robotics by Dr. Shailesh Shivan, Assistant Professor of Department of Computer Science, CUSAT, the practical industrial-oriented session on Sim to Real Transfer Hardware Integration by Dr. Pradeep Chatterjee, Robotics and Hardware Integration Expert. On the fifth day, Dr. Shrikant Madhavan, founder and CEO of Kabani Tech Private Limited, delivered an inspiring talk on idea to product in AI era, emphasizing innovation, ideation, prototyping, and product development. The afternoon session on stress management was handled by Dr. Meena A., psychologist and industrial trainer, who shared valuable strategies for maintaining mental well-being and productivity. The FTP concluded with a thought-provoking session on sustainability and SDG by Professor Dr. G. Madhu, FACT Chair Professor, CUSAT and Chairman. It is followed by Dr. Neetu M., Associate Professor of Jyoti Engineering College, who delivered a session on machine learning fundamentals, core approaches, and real-world applications. The FTP witnessed enthusiastic participation from faculty members, researchers, industry professionals from various institutes. The program successfully achieved its objective of bridging theoretical concepts with practical applications, fostering interdisciplinary learning, and equipping participants with knowledge of cutting-edge advancement in AI-driven robotics and vision system. Thank you. Thank you all.
Please take the പ്രശ്നമില്ലല്ലോ പാളയം സ്റ്റേഷനിലെല്ലാം എല്ലാ കാര്യം കഴിയല്ലോ ഇങ്ങനെ പട്ടി പോകുന്ന പോലെ അങ്ങനെ പോകുന്നില്ല അല്ല നാടൻ ഇപ്പൊ തല ഫുള്ള് പൊത്തോട്ട് തല ആ ഫ്രീ സ്റ്റൈല് നമ്മള് തല ഇതിനകത്ത്
Dear participants, can you please
ഫ്രീ സ്റ്റൈൽ നമ്മളെ വെയിത്തെടുത്ത് പിടിച്ചിട്ടില്ലേ വെള്ളത്തിന് തല മുക്കി പിടിച്ച് കഴിഞ്ഞാല് തനിയെ ബോഡി പോകും. അതാണ് ശരിക്കും ഒരു ഫീലായിട്ടാണ് ഫസ്റ്റ് അത് വെയിറ്റ് ഫുള്ള് നോക്കിക്കോ ഇങ്ങനെ പോകും.
Madam, please unmute. Madam, please mute.
കയ്യും തല ജസ്റ്റ് കൊടുത്താൽ തന്നെ മൂവ് ചെയ്യും. എനിക്ക് കൈ കൊടുക്കൽ ഭയങ്കര പണിയായിരുന്നു കേട്ടോ. എനിക്ക് കൈ കൊടുക്കൽ
Rajita madam.
വെയിറ്റ് ഭയങ്കര ഇമ്പോർട്ടന്റ്.
Dear participants, so to officially conclude the 6 days hybrid FDP on AI-driven robotics and vision system theory to practice, I cordially invite Dr. Anand Krishnan, head of the Department of Mechatronics Engineering, Jyoti Engineering College. So please.
Thank you, Nini madam. Good afternoon, one and all. As we come to the successful completion of the 6-day National Online FDP program on AI-driven robotics and vision system theory to practice, organized by the Department of Mechatronics Engineering, Jyoti Engineering College, in association with the IEA and ISTA, it's my privilege to propose the vote of thanks on official concluding the program. First and foremost, I express our sincere gratitude to the management and principal of Jyoti Engineering College for their constant encouragement, support, and vision in promoting such quality academic programs. I extend our heartfelt thanks to all the distinguished resource persons who shared their valuable expertise during the FDP. Special thanks to Engineer Amit Raman, Mr. Dhanum K. Dhanpal, Dr. Agil VM, Dr. Mervinjo Thomas, Mr. Jinesh KJ, Dr. Shailesh Shivan, Dr. Pradeep Chatterjee, Dr. Srikant Madhavan, Dr. Meera, Professor Dr. G. Madhu, and Dr. Needu M. for delivering insightful sessions that covered a wide spectrum of topics ranging from the intelligent robotics, computer vision, medical robotics, YOLO, hardware integration, sustainability, and machine learning. My special thanks to all the participants from academia, industry across the country. Your enthusiastic participation, active interaction, and eagerness to learn have been the driving force behind the successful of this FDP. I'd also like to acknowledge the dedication efforts of the FDP coordinators, Ms. Srishma and Mr. Ashik, organizing committee members, faculty members, technical support team, and student volunteers who work tirelessly behind the scene to ensure the smooth conduct of every session. As we conclude this enriching journey, I am confident that the knowledge gained and professional network established during these 6 days will contribute significantly to future teaching, research, innovation, and industry collaboration. Once again, I extend my sincere gratitude to everyone who contributed directly or indirectly to the success of this FDP. Thank you all. Wishing you continued success in your academic and professional endeavor. Thank you. Thank you very much.
Thank you so much, sir. Dear participants, this is for your information. Within 2 weeks, the certificates would be provided in the WhatsApp group. Thank you all for your cooperation. You may now leave the group, please.